Okay, number one, we're trying to decide what kind of sequence it is. 1, 4, 9, 16, 25. Looks like I'm adding 3, adding 5, adding 7, adding 9, so that's not the same number every time. So it's not arithmetic. For geometric, I consider what I'm multiplying by. Multiply by 4, and then, oh, no, it's not that either. So this would have to be a neither. Oops. Sorry, I'm having lead problems. I was switching pencils because I thought this one would have it, but okay. Neither. Number two, what are we adding? Well, I actually took it from 2/3 to 2/6. I went smaller, but I'm not going smaller by the same amount. Let's check to see what we're multiplying by. Looks like I'm multiplying the numerator by 1, the denominator by 2, so that means in total I'm multiplying by 1/2. Like 2/3 times 1/2 is 2/6, times 1/2 is 2/12, times 1/2 is 2/24, etc. So yes, we are multiplying by 1/2. That makes it geometric. Number three, looks like I went up by 7, up by 7, up by 7, up by 7. Yeah, we're adding 7 every time. It's not asking us this question, I'm just jotting that down, but that means it's arithmetic. Three, looks like we're doubling every time, aren't we? So our R value is 2. That makes it geometric. Okay, number 5, find the 20th term. Well, we probably could write the equation first. My first term is 7 times d, which is 50. I'm going to be plugging 20 in for in just a moment. Let me go ahead and simplify this equation before I do that. If I distribute 50n minus 50, combine like terms. So what we have here is the generic formula for any term. And so if I want the 20th term, I can plug in 20. If I wanted the 5th term, I can plug in 5. Whatever the case may be. Since this one's 20, I'm going to go ahead and plug 20 in there. So 50 times 20, that's going to be 1,000 minus 43 should be 957, I believe. Okay, I'm just going to confirm that, just make sure I didn't make a mistake. $957 is correct. Okay, so now number 6, the 9th term. This one I see it's got an R value. That R tells me it's geometric. So I'm going to kind of do the same pattern. I'm going to make the equation before I actually plug in the in. Oh, well, if I do, I'm going to have to need to know what my first term is. And this time it doesn't give me the first term. I'm going to kind of map out what I have for a sequence. My fourth term is 2,000. R means I'm multiplying by 10 every time from left to right, but I want to work backwards from right to left. So instead of multiplying by 10, I would divide by 10. So I can divide by 10 and get 200, divide by 10 again, get 20, divide by 10 again and get 2. So my first term, a sub 1, I see that that's 2. So for my formula, take your first term times your r to the n minus 1. There's the formula for any generic term. Now, if I want the 9th term, I plug 9 in for my n. So 2 times 10 to the 9 minus 1, or actually 8. So 2 times 10 to the 8th. And I'm going to get a big number. Let's see. Here, I'll show you. And here, looks like we've got 1, 2, 3. It looks like 200 million, I believe. Should have 8 zeros. Yeah, that's correct. All right. Now, starting number 7, write a rule. So really it's the nth term rule, write a rule for the nth term. That's basically what it's saying. So number 7 here, we know our first term is -7. Plus n minus 1 times d. Looks like we are adding 5. I need to distribute the 5. N minus 5. So we get 5n minus 12. A sub n equals 5n minus 12 is the equation. For number 8, I don't know the first term, so I'm going to kind of lay it out like I did on number 6. We don't know the first 3 terms. We know the fourth term is 3. This time from one term to the next, I'm subtracting 2. D is negative 2. So if I'm going to work backwards, I would do the opposite. I would add 2. So it's 5, 7, and then it's 9. So my first term I see is 9. So now a sub n equals my first term 9 plus n minus 1 times d, which is negative 2. I have to distribute that negative 2. So minus 2n plus 2. Combine the like terms. Negative 2n plus 11. Okay, now geometric. So we know our first term. We see we're multiplying by r, or I mean we're multiplying by 5. So r is 5. So first term is 1 times 5 to the n minus 1. So I would take that, of course, since we were multiplying by 1, I don't really need to write the 1. I could just say 5 to the n minus 1. That would be acceptable as well. Number 10, looks like I'm missing the first 2 terms. The third term I know is 125. Since from left to right I'm multiplying by 5. If I work backwards, I'm going to divide by 5. So 125 divided by 5 is 25. Divided by 5 again is 5. So I know my first term is 5. So my rule, first term times r being 5 to the n minus 1. Let's go to the back page. Okay, now you've got sums of series. Looks like this first one, it tells us up here it's finite arithmetic for number 11, but also I can see it has a d, so I know it's going to be arithmetic. So I use that formula. So sum of those 7 terms is equal to 7 times a1, we know that. an, this doesn't tell me an, it tells me n, but that's not the same thing. So we're going to have to figure out what an is, and we're going to do that by plugging in the numbers we have into the sequence formula. So we use our arithmetic sequence formula. First term plus 7 is my n, so 7 minus 1 times d. We know that d is 2. Simplify this. 7 minus 1 is 6. 6 times 2 is 12. So it's 9 plus 12. That's 21. So 21 plus 9 is 30. Half of that is 15. 15 times 7 is 105. Number 12. I see this one has an r, that tells me it's geometric. We do have a finite number of terms, and it says n is 5, so we know it's the finite geometric, and it tells us up here that this formula goes for that anyway. Now in your worksheet, just like you had these in summation notation, I've changed them for what I'm doing here. They also had a formula up here that's slightly different than the one I have written. They do the exact same thing. You can do that formula, which is kind of what our old textbook did. That's where that came from on this worksheet. But this is the one we've been using, so I went ahead and modified it on my worksheet. And so I'm going to use the formula that that we have been working with instead of the one that was originally on the worksheet. So sum of these 5 terms is equal to a sub 1, which is 3, minus a sub 1 again, times r, which is 1/2, to the power of n, which is 5, over 1 minus r. I'm going to plug this in the calculator. When you do so, be careful to put parentheses around the numerator. So I'm going to start with a set of parentheses, then I just type in the numerator. 3 minus 3 times 1/2 to the 5th. We're done with the numerator, so I close my parenthesis. Divide by. Now I'm ready for the denominator, so I start a new set of parentheses, type it in, 1 minus 1/2. I'm done with the denominator. I can close my parentheses, hit enter. There's the answer. So you can give your answer as a decimal. That's what this calculator gave us by default. Some calculators by default might give you a fraction. So what would this be as a fraction? It'd be 93 sixteenths. It's the same thing, so if you got that answer, perfectly fine. I like that answer. Okay, number 13. Let's see. It doesn't tell us what it is, but it looks like we're multiplying by 3/4 over and over again. So therefore, it's geometric. It isn't in dot, 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 so it's finite. So we're going to use, or sorry, not finite, infinite is what I meant to say. We're going to use the infinite geometric formula. It also tells us that that's what we're using for 13 and 14. Remember, before you use the infinite geometric series, you have to make sure that the formula is okay, that there is a sum. So the r value has to be less than 1, and it is. So there is a sum to this problem, so let's use the formula. First term was 2 over 1 minus your r, so 1 minus 3/4. Now we can certainly do this problem without the use of a calculator, but we can also use it. 2 divided by, now the denominator has a couple terms, so I do parentheses, 1 minus 3/4, and we get an answer of 8. Number 14, looks like we're multiplying by 2. It doesn't end dot, 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 so it's infinite. There's a problem here. This r value is larger than 1. So this, we would say, it diverges, or it's divergent. It's not convergent. So there is no sum. So we would answer no sum. Okay, recursive rules. First 5 terms. First term they tell us it's 2. Write it down. Then use the formula. So a term, you take a term and add 10 to it. So plug in 2. 2 plus 10 is 12. That's our next term. Then we'd plug in 12. So 12 plus 10 is 22. Then plug in 22. 22 plus 10 is 32. Then plug in 32. 32 plus 10 is 42. There's my first 5 terms. That's what it asked for. Number 16. Our first term is 4, so write that one down. Now it's saying, hey, take your term, plug it in for a sub n. So 5 times 4 is 20, plus 2 is 22. Then it's saying, okay, now take 5 times 22 is 110, plus 2. That's 112. Now take 5 times 112, that's 560, plus 2 is 562. Then take 562 times 5, 8, 10, 12, something like that. Okay, I'll just go ahead and type in the calculator to make sure. 562 times 5 plus the 2 gives us, yes, in fact, 2812. Oops, I don't know why I started to circle that answer. The whole thing, no. There's the 5 of them, should all be boxed or circled. All right, now write a recursive rule, 17. Number 2, or there's 2 parts. Don't forget the a sub 1, that's the part people forget the most. List what the first term is. The first term is 12. So that's part of the answer. Then, how do we get the next term? How do I get a sub n plus 1? Well, it looks like I have to subtract 4 from the preceding term. So take the a sub n, subtract 4. That's your recursive rule. Number 18, our first term is 200. The next term looks like I'm dividing by 2 or multiplying by 1/2. So I'm going to write it this way, 1/2 times a sub n. You can also have said a sub n divided by 2. All right, and that's the end of the worksheet.